Hey guys, Cody here with part 4 of the footprint tutorial series. And on this video I'm going to show you guys how to make 3D footprints as shown here, as well as this particle effect, and we'll also be adding a new custom decal. And let me just show you the side view. So what you see here is some tessellated material types that's being interacted with based off of my footprints. Alright guys, so let's get started with video number 4. So first thing we need to do is create a new snow material. So we'll hop over into our textures folder. We can right click on the snow material we already created. We can duplicate it. We'll call it Snow 3D. And we'll also import the snow height material, which I'll provide in the description below. And once I've imported that, created the new Snow 3D, we can pop this open and start working on it. Alright, first thing I want to do is drag this pin and throw it into the emissive color. Next I'm going to click on the output here, head on down to the bottom of the details panel until we get to tessellation, and I'm going to choose P in triangles. And that opened up these two pins, so I'm going to first pull off the tessellation multiplier, and I'm going to add in constant, which is just a number of 0.5, and that will control the tessellation multiplier. And then next we need to set up the actual world displacement. And to do this, I'm going to create a texture object, and I'm going to grab the snow height, which I created earlier. I'm going to pull off this pin and add it to a world aligned texture. Next I'm going to create a vector by holding down the 3 key, left clicking, and I'm going to drag this over into the texture size. And here I can determine the actual size of this world texture, so we'll do 64 cubed across the board. Once we got that done, we can grab the XYZ texture, and we can multiply it by the tessellation height that we want. So for instance, if we want it to be like 10 high, we can throw this in the world displacement, and now that's going to add the extra 10 height across the board. But it's kind of hard to see because it's happening on all sides, and because this is going to be snow, we really only want it to happen on the top. So to do this, all we have to do is create a vertex normal WS, and then we're going to multiply this by a vector. Again, hold down 3 key, left click to create a vector. And we're going to set this as 111 for right now and throw this into the multiply. Now I want to show you what this does real quick. So I'm going to right click on this multiply node and I'm going to start preview. And as you can see, the vertex normal is applying this vector here to each side based on the color that it is. So this is really useful if we want to select any particular side of a surface. Now as you can see, it works on multiple shapes and kind of has some nice fading effects. But for a flat surface like we're going to be using, we really only want the blue side here, the top, to have the snow on it. So all we have to do is head over to the vector and change red to 0 and green to 0, and now only the blue is going to show up. So once we have that set up, we can multiply this directly into our tessellation here, throw it into world displacement, and we're going to right click to stop preview, and now the tessellation of 10 is only happening on the top surface. And that's exactly what we want. Okay, so you'll notice that there's a gap in between here. That doesn't look very snow-like. So to fix that, all we have to do is, again, click on the output, head on down to the tessellation section, and where it says crack-free displacement, we just want to check that box. And there you go. That kind of connects everything up, and now it's starting to look more like snow. So we will apply and save this. So now that we have the basic 3D snow materials set up, we can save this, head back over into the map, and what I want to do is actually create a landscape. So we'll head on over to the landscape tab up here. And under number of components, we can set this just to 1. Doesn't need to be very big. And for the material, we will choose our 3D snow and create. Oh, there it is under there. Okay. So I just need to remove the floor to see it. And I can sculpt it up if I want to. I can modify it however I want, but I'll just add a little bit of a sculpture there. Sculpting. Alright, so let's hit play. Let's see what we got going on here. So you'll notice the character's feet are now sunken into the tessellated snow. That's what we want. It's part of the terrain. We also want that as well. You can apply this directly to objects. However, the tessellation will be affected by the scale. So it is something to note. Alright, before we jump over into the third person blueprint, I want to import another texture, and I believe this was called Snow Footprint. I'll also be providing this in the description below. So I'm going to add that to my textures here. Again, Snow Footprint. And I also believe there was a specular version for this, which I will provide as well, which should be called Snow Decal Spec, something along those lines. Okay, so I'm simply just going to right click on this, create a new material, and we can just call this Snow Footprint Matte. Double click on it. We already have the texture sample because that's what we created from, so I'm just going to copy this, throw this into the specular, and choose the spec. Nice. Alright, so once we have that, I'm going to switch it to square. So this is kind of like a basic footprint hole that we can use. And we're also going to want to drag off of this pin and set the opacity. But first we need to click on this, change the surface to deferred decal, because that's what we're using. And by default, it's set as translucent, so now we can pull this pin off into the opacity like so, apply it, and there we go. Alright, so let's head over into our third person character, and for the spawn decal, we're going to choose that material that we just created, so Snow Footprint Matte. And I want to change the decal size, so we'll make it 80 by 80, and we'll change the height to 80 as well, just to make it nice and big. For the rotation, we need to change the pitch to -90. And for the yaw, we want the yaw to be, now this is the general rotation that the player is going to see. We want that to be random, right? So let's do random float range. Plug this in, and we'll make it 360. So that way it'll spin around randomly on each footprint. So we can compile, save this, and let's test it, see how it looks. So now it's creating those decals based off my footprints in a random circular rotation. Pretty subtle, but perfect for what we're trying to do. So now we want to create a unique variable, which will be a decal component based off of every footprint that we want to affect the tessellated materials. So this is where things can get a little convoluted, and if anyone out there has a better idea of how to accomplish this aspect, I would really be interested. But for right now, what we're going to have to do is we're going to have to create 40 unique variables so we can have a nice smooth transition. So let's start off by creating our first one, which is going to be called footprint lock 1. And we're going to put this in a category called footprints. We'll call it snow footprints. And then we're just going to have to create 20 more of these. So again, footprint lock 2. And it looks like I have to choose the category again. Okay, now we need to make 20 more, which are going to be for the blend effect. So let's add another category for these, and we're going to do new variable, and we'll call it foot blend lock 1. And we'll call this category snow footprints blend, just so it's a little easier to see what's going on there. And again, we need to create 20 of these. Okay, so now that we have our 40 unique footprint decals, we're gonna set them up. So grabbing not the blend, but the normal one, we're gonna drag these all out here and we're gonna be setting them. Okay, now I just need to organize them a little bit. Okay, and then I need to hook up the return value to each of these. Okay, and then I'm going to pull these out a little bit. And I'm going to pull off of here and create a multi-gate. Okay. And this will have 20 pins. Okay, now next I need to power this multi-gate by an integer. So I'm going to pull off of here and promote this. And we will call this snow footprint select. And then we're going to take snow footprint select and set it. We're going to pull it out again and get it. We're going to add 1 to it, just plus sign. And when we set it, we're going to add 1 from whatever it currently is each time this is fired off, which will essentially make it move down the line all the way to the end. And when we get to the very last one, we're going to pull off this snow footprint select, set it to 0, and then we're going to have this end right here. And this will end here as well. So it continues on to perform whatever else we want it to perform. And we'll compile and save. All right, so let's head back into our level view, and now we're going to need to create a material parameter collection. So all we have to do is right click here, go to materials and textures, material parameter collection, and we'll call this snow footprint collection. We'll say even param collection. Okay. Double click on this, open it up, and first thing we need to do is make 4 scalar parameters. 1, 2, 3, 4. And this first one is going to be the radius of our footprint. So we'll call this radius, And the next one is going to be the hardness of the footprint. So that'll determine whether the edge is crisp or soft. And then we're also going to create a unique radius for the blend if we want to change that independently. So we'll do blend radius for this guy. Again, this is the footprint size. And then, if we want to have a different blend hardness, we can also do that. And for the different sizes, this is what I have set. So 25 for the radius, 0.8 for the hardness, 15 for the blend radius, and 0.9 on that one. All right, so save that. We can minimize these, and I'll show you where we hook those up in a little bit. All right, so now we need to create vector parameter values, and here we're going to have to make a lot, 40 in fact. So let's go ahead and do that. And we're going to have two types, just like the blend and the normal snow footprint. So for the naming conventions, let's call this location 1. We'll call it foot lock 1, and then we'll do this 20 times. Okay, and now we need to make a second set. So we will call these blend lock. Yeah. Okay, so we should have 40 parameter values here. It's a zero-based system, so that's going to leave us with 39. Okay, so now we have foot lock 1 through 20, blend lock 1 through 20, and we have our 4 scalar parameters, so we can save this. Don't forget to save. This is a great time to save. And let's head back. We can close out of this. Let's head back into our 3D snow textures. So I'm going to go to textures and snow 3D. We'll maximize this. All right, so in here we're going to want to right click and type in collection parameter. All right, and here we can select the snow footprint param collection that we just created. And then on this drop down, we'll have all of these different values to pull from. So first, let's grab the radius. I'm just going to copy paste this. We'll grab the hardness. And I'll make another one. Pull this out here. And we'll grab foot location 1. And you can click this arrow to make them a little bit more manageable. All right, next thing I want to do is create a sphere mask. And a sphere mask, by default, when applied to a material, will make everything within that sphere mask visible, but everything outside of that sphere mask invisible. So the opposite of a footprint, because a footprint makes, we want that indentation to be invisible and everything outside it to be visible. So here's our sphere mask. To inverse it, all we're going to do is a minus or a 1 minus. So 1 minus is going to inverse this process and make it backwards. We're going to take the radius and plug it into here, and the hardness and plug it right into here. So this, our parameter collection will power the sphere mask's radius, so the size, and the hardness. Okay, next thing we're going to do is go over here into the palette, and we're going to type in world position, and we'll grab this and plug this into our A. Then we're going to take our foot location, and we're going to create a component mask for it, which will not include the alpha. So we're leaving the alpha out, so it's just RGB, and we're going to plug this into B. Okay. Then we're going to pull off of here and multiply. Pull this down here. And now we're going to repeat this process 20 times. So copy paste, change the foot location to the next one down, 2. We're going to pull off this multiply and throw it into this one. Okay, now I'm going to take these 4 and repeat them 5 times to kind of speed things up. And then I'm simply going to change out the foot location. And then I'm just going to hook these up. And over here, I'm going to pull these all together. And by holding down the control key, I'm going to grab all these wires and put them into one single world position and one single radius and hardness. Again, holding down control to do this. And that just kind of speeds things up a little bit. Okay, and here we actually don't need this first multiply, so I'm going to delete that and connect this directly into the second one. All right, let's apply and save this. Okay, so now all we have to do is drag out of here, and we're going to multiply this into our tessellation. So multiply, and where's our tessellation? Right here. And we should probably start using some comments at this point. Okay. So that should be good for all that. Let's go ahead and test it. And first we'll apply. We should probably save all this again just to make sure. And this is going to be my first test, blind test. So we're doing it together, guys. Let's see if it works. I'm running. Oh no, I don't see any impact going on. Definitely not working yet. All right, guys, we are almost done. We have a couple more steps, and then we're going to get through this, and we will be moving on to the particle effects, which at this point, I think I'm going to have to push the particle effects to a 5th video because this is quite a long one. All right, so we have all these set up. Now we need to activate them, right? We need to set these locations, and we can do this in our 3rd person blueprint. So let's close out of here for now. Head back over to our 3rd person blueprint. Here we go. Okay, so let's make a little bit of space here. And I'm going to move this guy up here. And now we need to set those vector parameter values. So let's type in set vector parameter value. Okay, so off of here, we're going to make a sequence. And we can hook this guy up to here. And we're going to make 20 pins. Okay, so next we want to get the world location of the footprints to hook up to these vector parameter values. Because a vector is 3 numbers, which can also define a point in space. So let's take this parameter value, and we want to get world location. Let's see if we can do this. Take off context sensitive. Under transformation, get world location. Okay, good. And then under the collection, we want to select our snow footprint param collection that we created. And on the drop down, we're going to select footlock 1. Footlock 1. And then we're going to take this, repeat it 20 times. Okay, and then we're going to go ahead and change all of these locations down the line. 1, 2, 3, 4. Now this is good. These needs to be all these around. And notice I also. So block 4 is 4. Okay, now, you know what? I'm actually not going to use a full sequence here. I will use just a normal sequence, or actually I'm going to throw both of these into the first one and just connect them all up. and connect that to there. Alright, so now we need to get the target footprint, and we set those up earlier, so we're going to go to our snow footprints and get each corresponding footprint. So 1, 2, 3, 4, 5. And 20. Okay, so these should all be hooked up properly now. Make sure that each of these are on the right foot location. We're not using the blend yet. That's a whole nother ball of wax, so we will get there. But let's go ahead and compile and save. And I'm going to test it out. So let's hit play and see what happens. Kind of hard to see, but are there indentations or not? Yeah, it looks like there are. Now, you'll notice that it's pretty difficult to see the indentations unless you've really pushed the camera down. And also you'll notice there, the tessellation does crack if your camera breaks it. So you have to fix that with camera blocking volume or something like that. So let's see why or how we can fix the indentation to be more visible. And the first thing I want to do is probably just adjust the lighting. So let's grab our world lighting here. And I'm going to rotate it to make it more dramatic. Let's see. I want to make sure it's coming from the top and not the bottom. Try right there. So there you're getting a better impact visualization. Let's change the color maybe. To be honest, lighting, I'm still working on figuring out how to do lighting, so but there we can see better impacts. Unfortunately now we can't see the decal as well. But there it's having a nice three-dimensional impact on the snow. And let me show you the tessellation that's going on. And we can do that by jumping into our texture, our 3D snow texture. Click on the output here and go down to wireframe, and we're going to check wireframe, apply, and let those shaders compile. Alright, so here's the tessellated surface, and as I walk you'll see the spheres are being dropped under my foot, or where my footprints are, and they're being dropped there in down the sequence of 1 to 20. So it's creating 20 of these sphere masks along the surface, creating that indentation. And as I move forward, once it hits 0, it's going to go back to 1 and cycle back through them. So the more you add down the list, the longer the footprints will stay on the surface. So that's the first part, the basic principles. I'm gonna go ahead and stop the video here because we can go into the blending in the next video and the particle effects. So my name is Cody. Thanks for joining me